Okay. To start with, thank you for this opportunity, Ron. It was a pleasure talking to you guys. Yeah. So for to start with, I will just show you a project that we did with Grok 3, uh, just that we did like last couple of weeks actually.
Hey, Anto, just
Yes.
do a quick level set. Gronk is the xAI LLM, correct? Just so everyone understands that.
Yes. Yeah, Grok is the chatbot for xAI. Yes. That's available on X, and also we launched an independent app. Yes. So both are available. So one of the main missions when we were building Grok was to make the chatbot as unhinged as possible. Like as of today, there are multiple chatbots out there, which probably like each company has their own use cases. Some is better at coding, some is better at research, some is better at search. And one of the main missions that we had was to understand the universe, and it has to be unhinged and unbiased. That's one of the reasons we made Grok 1 and 2 open source, and Grok 3 also will be open source as we progress. The Grok 2.5 is not still open source, but yeah, we will be open sourcing the current models as well. When we started working at xAI, I've been there for a year now, and we worked on the Colossus project, which is like 0 to 100,000 GPUs working together we made that happen in 122 days in Memphis, Tennessee. Even though I'm in Palo Alto as of now, we did not actually deal with the physical building of the Colossus project. We are involved with the software training, building the foundation models, the transform architecture, the NLPs, and all that, right? So when we built like Grok 1, which is mostly like a text-based model, it was like we wanted to be a personal assistant where you can ask different questions, answer any questions to you, whether it be scientific, whether it be like a personal companion, etc. Right? And then we grew from that to launch our Aurora project, where we said, "Hey, like, there you go. We have like text to image based model where you can generate ultra realistic images." From Grok. And one of the difference that we made was that we wanted it to be kind of like similar to the real world environment, where if you ask a prompt, hey, make a Cybertruck in Mars, it has to be an actual Cybertruck that's actually placed on a Mars, right? It cannot be fully imagined. So we had to take a lot of real world examples and make it unhinged so that the AI does not hallucinate all of the image, rather a partial portion of it, and make it happen, right? One of the methods that we used for that was definitely RLHF. We did regressive training. We had like a lot of humans training one AI into kind of like preventing the hallucination nature that came out, and kind of like perfecting the model almost every day. Grok 3 is much more advanced version compared to Grok 1. It's like through the roof when you compare the model to what Grok 1 model is all about, right? It has all voice, it has image, it has like it can recognize a lot of PDFs. It has a search feature called Big Brain, and it can also think deeply. So one of the biggest advantage I'll definitely say is the deep search feature, where the Grok can almost do a research for you based on the PDF that you upload on it, or even go through the internet, search from different sources, and get the right aspects for you to like kind of work on. What our goal was to make actually Grok write entire research paper by itself without the human even like going through like a kind of like a reasoning model. The Grok has to come up with an entire research paper instead of like just prompting to and forth. We might get there very fast. Um, As per, I'm sure that a lot of people have seen this. Today, I'll be going on a very high level basis. I won't be getting much into details of what's happening in the company, or what we did as a team or anything like that, because I cannot say more about that. But this is much on a higher level. Yeah. As per the launch, we kind of like launched Grok 3 way before it even got released to the public. We had different pseudonames, including Chocolate. We had a lot of developers working and chatting with Grok on a daily basis. We had like millions and millions of outputs coming in probably every single day. And this was the first model to pass the 1400 benchmark in the chatbot arena, which is kind of like a big deal when it comes to like chatbots. DeepSeek was definitely good. O1 of ChatGPT was definitely like a kind of like a compelling model as well when it came to like math, science, and coding. It's more of like I would say the one of the tweaking factor when it comes to these kind of parameters is definitely the reasoning model that we put into it on how better the model can actually reason when it comes to accessing the paper, getting the information from the internet, scraping different information from different websites, all those kind of stuff, right? On the other hand, we also had put a lot of guardrails, so it does not defy any ethics. So that's one thing that Elon definitely made clear to us. We cannot be unethical with the data collecting. So most of the data is from open source data out there, which is like public information available on the internet. We also have other data sets coming in from the medical field, from the from the law firms, from other kind of like proprietary, not proprietary, other kind of like what do you call niche environments as well. Um, one. Yeah, okay. So I don't know if the crowd here understands large language models. If you want me to go over it, I can definitely go over it. But this is like the overview. This is like the most simplest way of how LLMs work on a very kind of like a primary school level. So yeah, we take like a massive data set, which is what I was talking about. We apply that to deep learning and transformer architecture. Transformer architecture is where all that NLP is working on. We do like a deep learning algorithm when the model kind of learns itself, takes the data, sorts it out into tokens. The model learns on how different parameters work, different data sets work, convert that in tokens. Even the neural network architecture is like matching different tokens together to find which word or letter goes after that next, right? So one of the questions or one of the things that we had was how many R's are there in Strawberry? Most of the chatbots got that wrong initially, so including ChatGPT. We're like, oh, like there are like four R's in Strawberry or like five R's in Strawberry, right? That's because most of the models do not understand that it's a word or it's a fruit or it's like it's a red object with like green leaves on it, but rather it's like a bunch of tokens together. And most of the time, the model hallucinates and says, "Hey, like there can be multiple repeated letters compared to the actual number of letters in a word or in a sentence, right?" The way most of the companies approach is definitely RLHF. So we used human tutoring and auto-regressive training to kind of like correct the AI multiple times, and even our algorithms were improved into actually making the architecture aware that okay, there's actually a word, there's a fruit. We have to associate different parameters into it so that it does not get the letters wrong, right? That's something that we kind of like perfected over time. Self-supervised learning is definitely one of the ways to prevent hallucinations as of today. There's also other different ways where we kind of like tweak the architecture into saying, hey, like there's auto-regressive learning where it kind of like goes back to backdates all the data and kind of like says, hey, like this output is wrong. You got to go back to the beginning and kind of like create more outputs as it comes. I'm getting. Okay. All right. Uh, yeah. And we came from what we call as LLM models, and we are entering into an arena of like multimodal AI. So multimodal AI is where we take different data sources. It's not just text. It's not just the publicly available news data or like articles or this content that's available on the internet. Rather, it's more of images where we use diffusion models where we split the image into RGB noises, where we take each pixel, apply noising layer, and deconstruct the images to form a completely new image that's kind of like trained on like millions and millions of like different image data sets. We have an internal model at xAI. It's not like a plug and play kind of like structure as of today. And also audio. Audio was one of the most key components. Well, it was a tough part when you actually train a chatbot like Grok. You need like audio labeling, which is like you need to recognize different pitch of voices. One of the goals we had was to make Grok sound just like human. The breath, the human breath, the pauses, the way, the accent, the way that the human talks has to be fully replicated. So the one thing we had to do was like label the audio. So just like how you label the text, label the images, we also had to label the audio, probably millions and millions of hours of audio data, right? We took it, we created, have different actors performing different kind of like skits, and like different conversations taken into it to build different models of Grok. So whether it be unhinged, whether it be a professor, whether it be a chatbot companion, all the versions of Grok 3 you can see on X or on the app is trained on different mini data sets from the audio model. And it's kind of a tough project, but eventually we got like a really good output from it. And that's when, yeah, the public came to know about Grok and the voice. We will eventually include more voices as well. And so now it's a single voice. But yeah, we will include more diverse voice accents and all that into the models as well. The fourth is definitely video. xAI is not into video as of today, but video is definitely in the pipeline where you can actually train the models on large video data sets. You take large amount of video, probably like hundreds of millions of hours of video data sets, kind of like break it down to millions of hours of tokens, break it down and convert that in images, apply that into diffusion models, apply noising layer, apply denoising, and attach the LLMs, 13 billion or 14 billion parameter LLMs into it and say that, hey, from text, we can actually recreate a video. One of the probably a good example for the current version of Grok 3 when it comes to multimodal is definitely the game engine. So you can just create games just by coding. So I would say it's really Grok 3 is really good at coding for probably 3,000, 4,000 lines of code, which is unbroken. And you can just apply it on Replit or some other platforms to just take the code base and convert that into 3D game. Eventually we'll get to a place where you don't actually need to have the coding. Rather, it's just fully based on text, right? So if you write in the text, it will actually convert that into 3D games where people can interact with 3D simulations, where people can actually do designs and like architecture and civil engineering, all those kind of stuff, right? On the other hand, there's also a factor called computer vision, where the models was trained really good enough to kind of like recognize different patterns from clustered images. So let's say that there's a very clustered room, and if you ask Grok, hey, like, do you see this kind of object in that room? It was so good at picking it up and kind of like saying, hey, like here the object is that was like done over a period of time using autoregressive training and all those kind of stuff. And that's one of the kind of like the precursor to how we got better at recognizing medical images as well. So Grok is like really good at recognizing CT scans, MRIs, X-rays, and all that. One of the examples that I can give you is that there was this mother who came to us saying, "Hey, her daughter went through like probably 10, 14 doctors, and she had a pain in the arm, and they couldn't find out what the reason was. So eventually, the mom got fed up and kind of like uploaded the medical images to Grok, and Grok actually found like a hairline fracture in the bone, which all these doctors missed out, right? So, which is kind of like a good thing when it comes to like actual positive applications of AI that the Grok could find something that the actual doctors couldn't do with their naked eyes, right? So they took the report from Grok and brought it back to the hospital, and they said actually they missed it out, right? There's actually a problem. So Grok is really good at kind of like dissecting the image, taking out each pixel and knowing what is wrong because it's trained on millions and millions of hours of data from thousands of doctors out there or millions of doctors out there, right? So yeah, there's like a million eyes instead of one doctor seeing your data at a single time. So eventually that model will also get really good. As you can see, this is a project that I'm doing currently. So this is the next step for AI, which is definitely simulations. So that comes into simulate where simulations are used for training robots. It's used for factory automation. It's used for like autonomous vehicles, where one of the biggest constraint when it comes to autonomous vehicles is definitely the training time. So if you look at industries like Waymo, right? Waymo took almost 14 years to train its cars on the streets of San Francisco. And to date, if it wants to launch it into a new location, let's say on the some in New York or in China or in Europe, it's still not trained on those data sets. That's where a simulation model can come in and say, hey, like here is the it can create a scenario based. Oh, it's like actually snowing and it's on a slope and like a slippery road, and have the models train on an unaware environment, and it can be the launching phase of the actual robot can be kind of like reduced from 14 years to probably like down to 1 year or 2 years. When it comes to factory automation, the robots that's working on, if it's trained beyond what it actually sees through the cameras, it can actually navigate through a diverse field of environments and perform a variety of tasks, especially when it comes to Optimus or any other humanoid robots out there. It's mostly one of the biggest bottlenecks is the training time. It takes a long period of time to train it. I cannot go in depth into how the robots are trained as of now, but yeah, it takes a long period of time to train it and also millions and millions of dollars into perfecting each task performed by the robot, right? And there is like 35 to 36% inaccuracies or error rate, which is kind of like very bad when it comes to human robots. It's like generally, it's not, I'm not talking about Optimus, but it's on a general scale as of today, the human robots have 30 to 36 percent error rates. But simulation models can greatly advance that. It's like the data sets that you get by human training. If that is like 1,000 different data points in a week, simulations can definitely give you 100,000 data points in a week. That's the advantage that a simulation-based model or LLM-based model combined will bring into the field of robotics and simulations. We are getting into an era of agents. So we will see. So since Grok is an open source project, it's very starter friendly. It's very malleable. It's very transparent on the data, on how it can be trained. Anyone can take it out and kind of use it as an API or even fine tune the niche apps or models based on Grok, right? So let's say that you're building a healthcare-based app which wants to recognize, medical images or analyze doctor reports, right? Grok is definitely good for that. So you can take the Grok open source version and put that into your app, and it can do the task much better, right? And since it's open source, it's transparent, it's much cheaper compared to any other models out there. Uh, yeah, but this is one of the use cases that I was talking about. Like there are multiple other use cases. Just say that compared to large language model, like large models like OpenAI's or Llama, they're definitely good. But when it comes to like niche use cases, definitely open source model or a small language model is definitely has way more advantages. There are also a lot of models available on Hugging Face where a lot of founders can use and take it and kind of like plug into their apps to make it perform better or even fine tune it or play around with the model to actually be better at one task rather than the model performing 100 different tasks at the same time, and none of them are so good, right? So one task which can be corrected 99% with very minute error rates, that's a way to go as a founder for sure. One of the things that I want to address is that right now we are in a race for accelerating the growth of GPUs. So there are like GPU clusters popping out around the world, around the US, right? So in order to go from LLMs to probably a simulation or a game engine, xAI will definitely have to double the size of GPUs, from probably from 100,000 to 200,000. And the goal is definitely to reach 1 million GPUs in Tennessee, in Memphis, in the coming years. But that will require a lot of power, and power is scarce. So if you want to power 1 million GPUs, that will take half of the US household power combined to run that data center, right? Which cannot be done as of today. Right. So that's where we need to look for other source of power, which is nuclear power plants. So 1 million GPUs require 24 nuclear power plants to power it. 200,000 GPUs will require 6 nuclear power plants to power it. So depending on the megawatt out, the capacity of the power and all those kind of stuff, right? So that's a thing that we are all talking about. What alternative solution is there for GPUs? We know that there are two companies which is majorly controlling all of the GPUs in the country, which is NVIDIA, AMD. But are we actually putting in more research into building a more efficient chip, which requires way less power and performs way better? That's actually something of a thought process that everyone is going through as of now. People are looking into NPUs, neural processing units, which is like an alternative for GPUs. People are looking into QPUs, quantum processing units. So we are in a quantum race as of today. So Microsoft, Google, they're all coming up with great breakthroughs in quantum technology. There is definitely a possibility for that. I've been talking to IBM directors at IBM on how they can solve this problem. So it's still in the research phase. I don't know. It can be kind of like possible in the next 5 to 10 years. And with AI, quantum technologies and particle physics is greatly accelerated. Even the power issue can be solved using AI. So the things that we took almost 50 years to accomplish can be done in probably 10 years using advanced reasoning, advanced research model that we put out using our models, right? Yeah, so I do run a nonprofit quantum society in the Bay Area, where we encourage a lot of AI engineers from all over the places, like from OpenAI, Anthropic. We have like people from IBM, Google, NASA. I used to work in NASA before I joined xAI. So we are creating a community of people who will actually find alternative chips or create breakthroughs in this field and eliminate the need for nuclear power plants, right? So uh, it's still growing. We do like a lot of educational stuff like in Stanford and in a lot of high school, from high schools to even like college students. We do like a lot of initiatives over there. We also kind of like have like a research institute or research lab where we call in independent researchers who do research on chips or even in quantum technologies and assemble them together to actually experiment on different stuff. We have a couple of scientists who are actually working in these fields as of today. Yeah. So the future, what we envision for the future is that the GPUs or the compute as of today is very primitive. It's kind of like binary systems, zeros and ones, or silicon chips, right? But to actually achieve, so these are the two takeaways. So the way Sam Altman believes in AGI is definitely a better reasoning model. Like if the AI is able to reason with you and ask you questions on what you're doing, that is the path to AGI. But the way Elon believes in AGI is totally different. The way Elon believes in AGI is definitely a spatial intelligence, where the AI is able to navigate through a space, able to actually kind of like understand, hey, this is the object, this is a human, and understand the way a human does, right? So it's not like we are not zeros at once. We do, if I want to lift up an object, I don't like go ahead left, right, true, false, right? Rather, it's like I have awareness of the surrounding. It's like different neurons firing at the same time, making me conscious, spatially conscious, making me environmentally aware, right? That's the way to AGI. So that's where LLMs are not as are a primitive, so primitive for AGI compared to a simulation-based model. Simulation LLMs, voice model, multimodal AI will definitely take us to a true AGI. And in the future, where we actually want to create a truly conscious AI, which is like actually able to invent stuff, right? So that's the goal that we all want to achieve. So where the AI actually wants to invent stuff or create something from scratch, we will definitely need a better computing solution for it. But that's not possible using GPUs, right? And that's where quantum or something else comes into play and say, hey, we are thinking in non-binary terms, where it's a qubit working in different parameters to make the thinking much faster, to make the NLPs work much better. So that's the race that we are in.